Hello everyone. Today we'll be solving EDEXCEL IGCSE 921 Chemistry Paper 16 May 2021. In this video, we are going to be solving from question number 5 to question number 7. This is a part 2 video. Question number 5. This question is about alkanes and alkenes. Complete the boxes by giving the missing information about the alkane with the molecular formula C2H6. So C2H6, the name of this particular alkane will be, since there are two carbons in here, so it will be ethane. And the empirical formula is the simplest ratio. So C2H6 will be divided by 2. So the empirical formula will be CH3. And the displayed formula for this particular compound is going to be 2 carbons in one row. And then we're going to fill up 4 bonds for each carbon by adding hydrogen. In this way, we're going to add 6 hydrogens. In that way, if you notice, each carbon is now having one single bond with another carbon and single bonds with hydrogen. Part 2. Complete the chemical equation for the complete combustion of the alkane C2H6. So C2H6, when we burn it in presence of oxygen, first of all, we'll have to notice there are 2 carbons in this here, in this particular left hand side. We're going to mention 2 carbon on the other side. Then we have 6 hydrogen in the left hand side. We're going to write 3H2O. Then we're going to count the number of oxygen, 2 into 2. So 4 oxygen here and plus 3. So total 7 oxygen, which means 3.5. So 1, 3.5, 2, and 3. However, balancing like this, all right, gives us a fraction. So what we are going to do is we're going to multiply both sides by 2. That gives us 2, 7, 4, and 6. Then we're going to make all the other number disappear. So that's how you do the balancing. Incomplete combustion occurs when the air supply is limited. Give the names of 2 products of incomplete combustion. Incomplete combustion definitely produces carbon monoxide, which is a toxic gas. So we're going to write carbon monoxide. And incomplete combustion may also produce carbon, which is seen as soot coming out of many vehicles if the engines are not properly maintained. And the third thing that we can always mention is that this produces water, or we can say that steam. We can say water or steam. By the way, water or steam both refers to H2O, so not to worry. Part B, an alkene with molecular formula C4H8 reacts with bromine to form a compound with molecular formula C4H8Br2. What is the name of this type of reaction? Now, when an alkene, when an alkene joins with bromine, this is an addition reaction. So just the bromine gets added. So this will be an addition reaction. Part 2. Draw the displayed formula for 2 different alkenes with the molecular formula C4H8. So with the molecular formula C4H8, we can have but1-ene. So if we do the but1-ene, it's going to be like this. Remember, each carbon must have 4 bonds. So keep adding hydrogen until you have 4 bonds established to it. And since this is an alkene, there is going to be a carbon-carbon double bond. And the next thing that we can do also is that we can do the 4 carbons in one row while keeping the double bond in the middle and fulfilling the rest of it with hydrogen. So this is, there can be a third option. So I'm just going to write it like the third option. If you want to do this one, is that we can put 3 carbons in one row with the double bond and a methyl group in the side. And that in this way, we can also, make sure that we have all the bonds. This is also a valid structure. So yeah, feel free to do it as well if you feel like. Next, state the term used for the compounds with the same molecular formula but different structure formula. So a molecule with same molecular formula but different structure formula are referred to as isomers. So we're going to write it isomers. The alkene, part C, the alkene C3H6 can be polymerized to form polypropene. Complete the equation for the polymerization reaction shown. So for this particular polymerization reaction, what we're going to do is that we are going to keep the carbon-carbon single bond, break the double bond, and put 2 hands in 2 sides. And then the remainder of the bonds we are going to put in just the same location. and we're going to mention the end. Part 2. Two ways of disposing polymers such as polypropylene are burying them in landfill sites, burning them to release heat energy. Discuss the environmental problems caused by these two methods of disposal. So there are two ways of disposing of polymers, all right, such as polypropylene, and we can see that either we can bury them in landfills or we can burn them to reduce heat energy. Now, if we bury them in the landfills, the problem is that they fill up the landfill. They do not degrade. They do not burn. They do not decompose in the environment. All right, and if we burn it, then it can produce toxic gases. Question number 6. This question is about some of the group 1 element and their compounds. A teacher adds a small piece of lithium to a water in a trough. Give the 3 observations that are made when lithium reacts with water. So first of all, when the lithium will react with water, it will produce a lot of effervescence. It's going to move on top of the water. It's going to float on top of the water. It's going to become smaller, and at some point it will disappear, and it will also produce a trail of steam because it is reacting at a pretty high temperature. So since we have to write only 3 points, so we're going to say the one of the observation will be effervescence. The second observation will be it moves and floats. And the third observation will be it will get smaller, or we can say disappears. Other points that we can also write, we can name it as point number 4. All right, that is vapor trail follows. Part 2. After the reaction has finished, the teacher adds a few drops of universal indicator to the solution in the trough. Explain the color of the universal indicator after it is added to the solution. So once the universal indicator will be added, the universal indicator will turn purple, because when the lithium reacts with water, it produces hydroxide ions, which makes the solution alkaline. The next question says, write a chemical equation for the reaction of lithium with water. So when lithium reacts with water, it's going to produce lithium hydroxide, and it's going to produce hydrogen. So to balance the hydrogens, we must put a 2 in front of the lithium hydroxide. So there are 4 hydrogens. So now we can put a 2 in front of here. So there are 4 hydrogens in the left hand side. Now to balance this 2 lithium, we'll have to put a 2 in front of the lithium, and we will naturally find out that the 2 oxygens are naturally balanced. A student does a flame test to see if a white solid contains sodium ions. She cleans a platinum wire before using it for flame test. Explain why the student needs to clean the platinum wire. So basically, if there is any surface impurities or contaminants, all right, it will interfere with the color of the flame. So that's why the student needs to clean it. Part 2. Which of these is the color of the flame if the solid contains sodium ion? So we know that sodium ion's flame test gives yellow color. So the yellow will be the correct answer. Potassium sulfate is an ionic compound. Give the formula of each ion in potassium sulfate. So potassium ion is K plus and sulfate ion is SO4 2 minus. Next question. Part 2. The melting point of potassium sulfate is 1069 degrees Celsius. Explain why potassium sulfate has high melting point. Refer to the structure and bonding in your answer. So potassium sulfate has a giant ionic structure or giant ionic lattice. The electrostatic force of attraction between the oppositely charged potassium ion and sulfate ion, all right, is very, very strong. So large amount of energy is needed to overcome these forces and break the bonds. High temperature is needed to melt it. Question number 7. A student investigates a reaction between magnesium and hydrochloric acid. He uses this method. Step 1. Add 25 cm cube of dilute hydrochloric acid to a polystyrene cup. Step 2. Record the temperature of the acid. Step 3. Find the mass of a 10 cm strip of magnesium ribbon. Step 4. Add the magnesium ribbon to the hydrochloric acid. Step 5. When all the magnesium has reacted, record the highest temperature reached. Complete the word equation for the reaction. So magnesium plus hydrochloric acid is going to produce magnesium chloride. So we're going to write that down, magnesium chloride. And followed by that, because it's a metal plus acid, so it's going to produce salt plus hydrogen. So we're also going to get hydrogen. The thermometer shows the temperature of the acid at the start of the experiment. So we can see this is 20 degrees Celsius and this is 25 degrees Celsius. This is 21, this is 22, and this is 23 and 24. So we can see 22.4 degrees Celsius. Complete the table by giving the temperature at nearest 0.1 degrees Celsius. The temperature of the acid at the start in degrees Celsius. So it is 22.4. Highest temperature reached in C. So highest temperature reached, all right. So highest temperature reached has to be calculated because there is a temperature rise of 20.8. So we are going to add 22.4 and we're going to add 20.8 together and we're going to get this answer. So highest temperature reached is 43.2. So what we did is we added the initial temperature and the change temperature, and then we got what is the final temperature. Part 2. Show that the heat energy change for the reaction is 2200 joules. Mass of 1 cm cube solution is 1 gram. For solution, 4.2 joule per gram per degree Celsius is the specific heat capacity. All right. So for this kind of math, we are going to do Q is equals to mc del T. Now del T represents temperature change. Mass of the water in this particular experiment, mass is 25 cm cube of dilute hydrochloric acid. So the mass is 25. C is 4.2 and del T we got in the previous page, which was 20.8. And when we do the math, it comes 2184 joules. All right. Now, if we do this particular answer to the nearest, to the nearest hundreds, so we would definitely get 2200. So basically 2200 joules shown. Part 3. The mass of the magnesium used by the student was 0.12 gram. Calculate the value of the enthalpy change del H in kilojoule per mole of magnesium for the reaction between magnesium and hydrochloric acid. Include a sign in your answer. So, since we know the mass of that particular magnesium used, we'll definitely try to find out the number of moles of magnesium that was used in the experiment. So 0.12 divided by 24. We'll divide it by relative atomic mass. And we get the moles 0.005 moles. Now, Once we know the number of moles, for that we can find out Q, all right, which is basically Q divided by the number of moles, which means 2184 divided by 0.005, which is equals to 436.800 joule per mole produced. So we will divide this by 1,000 to get the answer kilojoule per mole. So 436.8 kilojoule per mole. Guys, that's all for today's video. In the next video, we're going to be solving from question number 8 to question number 10. All right, subscribe to the channel and stay with us, and you will get the solution of that one too. Thank you. Thank you for joining the video. Bye-bye.